This is a power transmission and distribution subject. This is a project that developed a conceptual prototype model of suspension type overhead line insulator. The lecturer for this project is technologist Dr. Sin Yi. This is a group member which consists of 6 members, which is Muhammad Haikal, Khairul Aiman, Atira Shamimi, Puteri Nazatul, Muhammad Farid, and Muhammad Mirul Amin. My name is Puteri Nazatul Iman binti Abdul Saad. My metric number is CN190207. I will present to you about the objective. The objective of this project are to design and insulate a prototype model of overhead line insulator suspension type that can withstand a 33 kV continuous AC stress voltage. The second one is to design suspension insulator type using a ball, plate, and a PVC. The third one is to study the main function of each insulation section and suitable materials. Scope project. The first one is to design 2 different suspension type of insulator using AutoCAD software. The second one using the different types of core rods for the 2 design. And the last one is observe the suitable materials that can be used for the insulator.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Halim. My metric number CN190224. Today I want to present my part is technical summary of chosen concept design. We have 3 concept design material that we use. First we have core rod, sheet and end fitting. The material rod that we use is PVC pipe size 2 cm. The length of the core rod of PVC pipe is 50 cm. The inner substances in the core rod is we use sand and cement to make a cement mortar. Second, the sheet is material used is a plate porcelain and bowl porcelain. The size of a plate is 25 cm times 3 cm. The bowl porcelain is size 25 cm times 3 cm. The creepage of the sheet is 124 cm. Then the last one is the end fitting that we use in the prototype is we have an end cap. The PVC end cap is size same like the PVC pipe for core rod 2 cm. The hang type is a metal hook that we use. The length of metal hook is 3 cm. Then we go to the equipment that being used in our prototype. First, we have decide on 3 plates and 3 bowls for the design. The bowl is placed between 3 plates for increase the creepage length. The material that we choose to use in this design for the 2 type of kitchen utensil is porcelain. Porcelain has stronger mechanical strength that can exhibiting and improve resistance to aggressive environment and longer lifetime. Then the plate diameter is large in order to lessen the strength of the electric field. Then we have apart from that, the plate and bowl arrangement so that they face downward because it can avoid water reservoir during the rainy water. Okay, then the water reservoir can function as the conductor and might cause for flashover for the insulator. The plate smooth surface and the bowl will drain the water or other liquid substances, avoiding a flashover. Because of the diameter of 3 plates, this design has greater clearing road distance. The material we use for our design is likewise porcelain. Following that, the core rod for this design is made of PVC pipe. This is because it is a long-lasting item and super insulator. We also use cement and sand to make a cement mortar to fill the PVC pipe for increase the efficiency of the insulator. Okay, for the core rod equipment that we use in the inner core rod, we use a cement mortar. First, insulating cement is frequently used as a backup to other refractories, ensuring complete protection and never risking heat loss and shield damage. Then, insulate cement has become a good backup option to primary refractory due to its capacity to refract heat and creating effective sealing. The last one for our equipment we use in the cement mortar, dry concrete is strong, has a high resistivity and is less expensive than silicone rubber, which has a high shear strength and is more expensive. Okay, that's all for my part for presentation about the technical of uh, our project. That's all. Thank you.
My name Nina Atira Syami binti Norlan, method number CN190181. My part is methodology of prototype construction process. In this part, I will explain about a block diagram for this project and flowchart. First of all is block diagram. First, research suitable material for insulator to high voltage. Our group member will discuss about type of insulator and material will use in this project. Second is draw the insulator design using AutoCAD. First, design using a 3 plate and 3 bowl, and second design using a 6 plate. Third is selected suitable insulator design. Discuss with group member and lecturer, and the suitable design is a first design that use a porcelain plate and bowl and forward using PVC fill in with cement and sand. Next is make a prototype based on drawing. For the drilling process, need make a hole to pass the bowl and plate to the rod and use a glue to stick the insulator to the rod. Between the plate and bowl to another should have a gap. To reduce a mechanical strain, the sizing of this prototype should follow the instruction. It is the rod not more than 50 cm and the clippage not less than 70 cm. Next is high voltage testing. Tests can prove the material suitable use for high voltage or not. And lastly, we can make an analysis and report. Next is a flowchart. First of all, select a group member. Our group have a 6 member. Then after that, doing a research about type of insulator and material suitable for insulator for high voltage. Then discuss it with group member and lecturer about drawing and material use. If yes, proceed to design a prototype. If no, the design need to change and make a improvement. After that, after design a prototype, we should measure a height of the rod. If less than 50 cm, need to adjust the height of the rod. If more than 50 cm, need to measure a clippage. If clippage more than 70 cm, we can testing the insulator. If no, we need to add a material. That's all my part.
Okay, hello, Assalamualaikum. Nama saya Muhammad Farid bin Nazri. Okay, kali ini saya nak terangkan pasal FMEA, failure modes and effect of analysis. Okay, FMEA describe a project as a process to evaluate how it may fail, as well as the relative effects of possible failure. To decide which component process needed the greatest adjustment, failure modes refer to malfunctioning methods. Failure is any fault of defect that affects the user or the environment. Failure might be future or present. The effect analysis examine how failure affect their surroundings. Okay, this is the failure mode of effect and analysis. Okay, the failure modes of effect analysis FMEA. This is the table that we set. Okay, first of all is what kind of failure. Okay, what kind of failure? The failure effect is what is the impact to the transmission line, environment, and user. Okay, the SEV is how severe the effects. Okay, the second one is the mechanical separation. The mechanical separation, the failure effect is the physical damage to the overhead line, and the severe effect is one. Okay, the partial breakage of dielectric shaft. Okay, the failure effects is the reduction in residual performance. The severe effect is 4. Okay, the cement expansion. The cement expansion is a PVC can break. The transmission line is cut off. Okay, the severe effect is 6. The internal puncture is a micro crack grow over time. That's the failure effects, and the severe effect is 6. The external flash jobber, temporary loss in insulation strength. The glaze in the porcelain melt and leaving. Kiranya that's the failure effects, and the severe effect is 4. Okay, for the next potential cause and the action recommended, which is the first one, what caused the failure? Okay, what are the action that be needed? Okay, the string flash over to the insulator, toughen the insulator, periodic, toughen the insulator, which is that for 2. The vandalism, poor handling during storage and installation, that's the potential cause. The action and recommendation is replace the insulator if it has been used for so long. Itu probably is for the insulator was too old. The porcelain manufacturing, we need for the action recommendation is inline inspection using the measuring instrument. Okay, the three potential cause is like lightning activity, pollution condition. Okay, we need the action recommendation is the periodic inspection. Okay, that's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairul Aiman bin Daud. My nomenclature is CN190190. Today I would like to present about safety risk assessment. Okay, for the introduction is the final what the report includes a safety commission from related to the safety risk assessment. Before the high voltage supplies are turned on, this form must be filled out. This safety risk assessment form essential because it's the least potential risk can arise during testing, as well as safety precaution that can be taken safeguard participants, student, lecturer and equipment while testing is being done. Okay, for the first hazard possible consequence, electric shock from high voltage, 33 kV AC voltage. Okay, person or equipment at risk, a person testing a prototype or working near to the apparatus. Okay, control measurement applied to eliminate or minimize risk. First, interlocking safety cage where the power can only be switched on the door is closed. Okay, second, the cage has warning lights and sign attached to it. Okay, second, for the hazard is eye exposed to the salt liquid when conducting wet test on prototype. Okay, next is a person who was present while the testing was done. Okay, control measure using PPE, personal protective equipment, such as safety goggles. Okay, hazard for the next is trips, person equipment, including individual in the testing environment. Okay, control measure apply. First, during the test, wear safety shoes, rubber shoes for the exact where the safety. Second, rubberize the testing area by covering it with it. Okay, next is spark or fire. For the next, those present in testing lab at the time and the instruments. First, the control measure applied and fire extinguisher available in the laboratory in case as fire for the testing. Second is set up smoke detecting equipment in the lab. Okay. Third is escape route and secure exit. For the any accident happen, we can go outside to the escape route or exit emergency door. Okay, next hazard is slips when conducting wet tests on the prototypes. Okay, person in the area when testing was conducted. Okay, for the control measure, first when doing the wet test on the prototype, proceed courteously and according to the step. Okay, that's all from me for the risk assessment. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Rami bin Kamian. My metric number is AN190087. So I would like to present about the laboratory HV testing. They have a few procedures and safety precautions before handling the test of insulators for the high voltage source for the test on the insulator. Procedures are divided into two types in conducting the test, which is in dry and wet condition. So for the first type is dry test insulator. Before student entering the cage, the power supply must be turned off. After entering the cage, students should connect the supplies and grounded to the insulator. After that, close the cage and make sure the light is turned off and continue to turn on the supply. Student must step up the voltage until the spark is shown on the insulator. So the third one is the maximum voltage that the insulator can support must be recorded and turn off the supply after done doing the test. So the last step is taking out the insulator from the cage after settle the dry test. For the second type is wet test insulator. Firstly, before entering the cage, wet the insulator with a salt water. After that, connect the supply and ground to the insulator and turn off the light immediately if want to test the insulator. Next, the supply should be turned on for ease the students seeing the sparks. Step up the voltage until the spark is shown from the insulator. So after that, after spark was shown, turn off the supply immediately. The last step is the insulator which had been tested must be taken out from the cage. Before high voltage supplies are turned on, the safety risk form must be filled out. This safety risk assessment form is essential because it lists potential risks that can arise during the testing as well as safety precautions that can be taken to safeguard participants. Firstly, a person who is testing a prototype or working near the apparatus need to interlocking safety cage where the power can only be switched on when the door is closed. After that, the cage also has warning lights and signs attached to it. Students who has present while the testing was done must using PPE such as safety goggles. Next is the individuals in the testing environment also need to wear safety shoes. The second last is those who presents in the testing lab need to make sure that the fire extinguisher is provided in case any emergency things happens. The last one is when doing the wet test on the prototype, proceed cautiously and according to the steps. Next, I would like to present about the HV testing result. At the end of this project, the best design of the suspension type insulator was chosen along with the technical specification that fulfills the specification of the insulators. Then, the specification of the chosen material was discussed in this section. The creepage distance of the insulator is defined as the total path that can be measured along the sheds and exposed core on one side's view of the insulator surface. So this is a dry and wet flashover test. So frequency is applied across the insulator and increased at a uniform rate, about 2% per second of 75% of the estimated test voltage, to such a value that a breakdown occurs along the surface of the insulator. The insulator already showing the spark when the voltage had been reached 8 kV in dry flashover test. Before proceeding the dry flashover test, the insulator to be tested is mounted in a practically manner. So after that, the insulator was sprayed by salt water at an angle of 45 degrees, and we need to make sure the precipitation should not be more than 5.08 mm per minute. So this is the wet flashover test. After that, when the voltage reached 28 kV, the spark is shown on the insulator, which means that is the limit voltage for the insulator in dry condition. So this is the table of the result for wet condition and dry condition. So in the right side is the image of the flashover or spark on the insulator. So for the last part, I will present about the results of insulator failure. First and foremost, the causes of failure of insulator are cracking and burn damage. One of the most factor of cracking is due to its stress produced in the porcelain and due to unequal expansion and construction produced in cement, Plate and porcelain. It caused by seasonal heat cold, dryness and dampness, or by heating of the insulator. The next is there is a flash from one plate part to other. It will cause overheating and will result into shattering of it. Last but not least is due to different climates, dry and wet condition, the porcelain body get expand in different rate. So that's all from me. Thank you.
Recommendation. The first one, instead of using a plate and a cup, try to use a bowl and a cup because that is a better material for it. The second one, use a polyethylene rod that is strong and more resistant than a PVC rod. Conclusion. In conclusion, the materials employed had an impact on the suspension insulator's performance. In an attempt to design type prototype overhead line insulator, the project's goal was accomplished. Selection is based on factors including electrical resistivity, sensitivity rate, strength, usability, and ability to reduce electric field. Because design 1 has a strong root core, good compressive strength, and is magnetic to a permanent magnetic field. It is used in this project. Thank you.